I'd like to thank everybody for being here and participating in the small workshop. We're very happy collaborating with Georgia Georgiou, with EACEA, and the girls from the company, also with Maria and the others from the Eratosthenes Center of Excellence. In fact, I believe that this kind of extension to the Eratosthenes Center of Excellence, to the program, is quite useful and covers a part of the activity that should be developed through the project, through the EXCELSIOR project. What we did here, we prepared some slides for you to show you how people, maybe the different applications related to forestry and some services we have been developing as a group for the Greek government during the last years, and show the extension that some people that get experience in working with GS and remote sensing can use in order to get some jobs, etc., in the future. So some, let's say, prospects related to the knowledge you get and how you can use it. Forestry is one of the first applications that remote sensing ever had. Professor Kunz maybe is here to agree with me, because he is one of the old professors in Germany working in forestry. Anyway, as you can imagine, forests cover a large part of the world, and satellites at the beginning were a very good solution in order to cover and get information about forests from above. That was originally the idea before people started using remote sensing in forestry applications. Of course, we started with satellite data. I think it was a very nice, excellent talk in the morning, how Landsat started and the history of remote sensing. But then more recently, we have many sensors on board of different platforms, such as airplanes, how you call it, UAVs, US systems, etc. So we have started from satellites, but nowadays we have different platforms. We have different kinds of data coming from different sources. That's the idea, really. Focus on different applications. I said I'm going to share with you some recently advanced applications of remote sensing forestry. Then the second part will be focusing on different national products and services we produce for Greece, for the government of Greece. And then finally, we're going to have some more light as well, some more general applications that are not really forestry, but are related to forestry issues. One important bit for foresters in order to apply forest management is how to map the tree species. This is an exercise we've done already with the Team Madason, with the Forest Department, through a live project they had on biodiversity. And that we had a collaboration with Maria on that. And we tried to cover the tree biodiversity covered in Cyprus. So it's not an easy task. You need lots of ground survey. Remote sensing is not automatically give you the solution. So we have to learn that whatever is done is a combination of data you collect in the field with some applications, some analysis done with satellite images. The specific exercise, actually, that does not relate to the slide, we didn't only use satellite data, but we had to collect also drone data, etc., to support the analysis done on the satellite images. This is an example comes from forest mapping. We have different forest types, different forest species, and in every slide we have also here the source of information where it comes from. It's very important to know the type of the forest, to know this forest species, because based on that, you have to start doing your forest management. And there are very nice forests in Cyprus. We are in close collaboration with the Forest Department, and indeed we think of how we will manage the good quality of forests in this country through the use also of modern technologies like the one we're talking about today. The assessment of the forest is, we have different assessments, like very much interested in the health, productivity, biodiversity, as I said before, and of course, there are other different important aspects to be mentioned later in the next examples. One thing we have been developing a lot in our unit, actually Nikos is here, he can talk more about that. We had a close collaboration with the University of Eastern Finland. The Finnish and the US Forest Service are top at the moment in LiDAR image processing. We had the project with the Finnish, with the University of Eastern Finland, so we had people from our group who are trained there. So what we have learned how to collect laser data, how to use them in order to produce wood volume, and through that, to be in position now to talk about how the wood volume is related to the absorbance of CO2. So we're one step forward. Every time we cut a tree, more or less, we know how much of less CO2 will be absorbed by our forest. We were lucky enough to have enough money, and we have some money found from the Greek Ministry of Environment. So we had a project running in the University Forest of Pertuli, in which we have now had to fly over the area. We had to produce algorithms in which we have measured the volume of more than 800,000 trees. For those who have forestry background, you know that the Pertuli forest is unique in the country. It has some unique aspects. It looks like very much like Central European forest. It's a fir forest. It's not a pine. It's a fir forest, 90%. And based on that, we're now in discussions with the United States Forest Service in collaborating data we produced in our forest and with data that are produced by the U.S. Forest Service in the Idaho area. We want to compare algorithms, etc., because they have a similar data set for the area of Idaho. So based on that, we were in position to produce a number of parameters, like vegetation height. I'm not going to go into details, but anyway, individual trees were difficulties, but I'm going to show you some ideas of what you can get by this data set. Canopy cover, important information. Canopy cover estimation, canopy base height, very important information for foresters. Also, we're talking about that we extrapolate from the unit level, from one tray to the plot level. That was really important. So you know where your productive forest is, and you know where your canopy starts and where it ends. It's very important in Greece, as also in Cyprus, to know which parts of the forest are more possible to get a fire and also to mitigate fire. Because the structure of the trees and the structure of the forest relates very well with the ignition of fires and also to the spread of the fire. Some other different aspects you can see here as well. It's not an easy task. It's not we just go there, we measure, etc. We have to cut a piece of wood. We have to use it to dry them. We have to measure them. We have to compare what we measure on the ground with what we can find is already there by the LiDAR data we have already collected. So you have somehow to match information collected by the sensor with the data you collect in the field. Another source of information is SAR imagery. I think there are more SAR sensors to come in the future, Stefan, as I heard today. I'm not an expert in SAR data, but we have some nice collaborators on that. Above ground biomass also can be achieved by using SAR data. We have started already talking about precision forestry. Maybe you know the term precision agriculture, but now we're talking about precision forestry. Precision forestry means that we have high resolution data. We have data for every tree. So every tree has a tag, has a name. And then we have started thinking of talking about how we can do the management on a tree species level. On a tree level, that's the future really. So this is an example of what we did in our field survey in the Pertuli forest. Talking about forest fire management. So as I said, we're foresters, but the main problem in our countries is fires. The main disaster comes from forest fires. I'm going to show you some slides on how we deal with that and what examples what service we've been producing for the Greek government. As you can see that we have three main phases related to fires, which is the pre-fire planning, very important. All the governments of Europe now focusing on this part because they have realized after 30, 40 years of discussing that it's better to give money before the event than giving money after the event. It's better to prevent than pay after the disaster. So this is very important now. We'll see how remote sensors can be used in these three phases. First phase, as I said, is the pre-fire planning. Second is the fire detection and monitoring. And the last one is the post-fire evaluation. This is a typical example we've been doing. This is an older work. Actually, this is to be published now. We're involved in one of the biggest Horizon projects at the moment called Fire EURISC as a group. And together with another 36 groups, will collaborate in developing a unique and unified map for the whole Europe based that focuses on the type of fuel. Fuel type is not vegetation map. Fuel type is vegetation map plus how vegetation burns. It's a different kind of information. How a fire can start and how a fire can be spread according to the type of vegetation. So it's a complex information. So we're working together with big groups from all Mediterranean countries, but also Central and Northern European countries, developing this for JRC, for the Joint Research Center. We have already developed the wall-to-wall coverage, and now we are working with the Greek Ministry of Environment, developing this for the Greek government. This will be in place by June, because the Greek government has a special office that was created last year after the large fires, in which, in the same office, we have people from the fire service, the civil protection, and the forest service. So they asked us, the contribution of the Minister of Environment plus Forest Service will be to deliver the field map through using the University of Thessaloniki. So each governmental agency produces something and puts on the table. And we're working together with Greek Forest Service in order to deliver this in time. So and the importance of this product is that they need to know, in case there are many fires happening in the same area, where to give the priority. Because according to what is on the ground, they have to decide on the fly, in real time, what the resources of different fire brigades, etc., should go. That's very important. And they are waiting for the results now. It will be the first time that a unified product that complies 100% with the European level product is used in the country. This is what we produce for GRC. This, as I said before, we have produced that for some parts of Greece, and our task now in the unit, we have many people working on that. I think Nikos is supervising them. Is it you or somebody else? You? Nikos is supervising the team in order to be ready to produce this for the whole country by June. Unfortunately, it's not a good year for us because we already have large fires in the country due to the extremely dry season this year. So our aim was to be there before the fire season, but I think we have to be faster to deliver even earlier, if possible. That goes to you, Monsieur. So straight. some other products we've been developing for ages. This is an old version of the famous. Anyway, it has been there for about 15 years now, more than that even. We have been developing automatically producing algorithms for automated burnt area mapping using object-based analysis in the beginning. Now, lately, we've been using lots of AI kind of methods. Actually, our colleagues don't like the AI terminology. But anyway, it's quite modern version of what we do at the moment. Through the years, we persuaded the Greek government and we collaborate permanently with them with the last 10 years. In the beginning, we developed together a national observatory forests, in which we have to create a forest management map for the whole country. And later, we have started producing the so-called the National Observatory Forest Fires, which is still in place. And we got a new product, a new contract last year for the next 3 years to produce automatically and on a permanent basis as a service, not as products anymore. We produce services for the government related to the post-fire assessment, including mapping, severity, and post-fire monitoring. This is a group of 3 different products we are producing. This is the new one we're developing now. It's related to the burn severity mapping. Talking about the project, the different things we're doing for the government, my group and myself personally, I'm very honored to be scientifically responsible for the first ever National Forest Inventory of the country, which started 2 years ago. It's already now, it's not finished yet. We believe that we'll be ready by the end of the year. We have one survey, National Forest Inventory happened in the 70s, 80s, but covered 80% of the country. It took them 20 years to complete it. Now it's the second effort, but they will complete the whole country this time. That's why we call it this first inventory. And then the idea is I don't know how many people working on remote sensing at the moment. That's why we have this example here, all over the country, because the University of Thessaloniki, we have the scientific, if you want, supervision of the whole work, but the work is done by, I don't know how many companies, 6, 7? More than 10 companies. More than 10 companies that are focusing on forestry and remote sensing. You cannot imagine how many people have been used and now are employed for the third year, consecutive year, using remote sensing, aerial photography, how you call it, interpretation, and exactly work on the subject. We are very proud as a unit because we create jobs for the foresters and for the people working in the field. Actually, we believe the reports will start to write the report by October if things go well, and by next January maybe will be available. The report will be available and the maps will be available for the public. This is some results of the classifications we've been doing. The whole forest inventory survey has got two phases. We produced using different data sets and image analysis, the so-called base map, and we have been working on the accuracy of the map for ages before we achieved 82%. But now all the groups working in the field are sending information back to the system, and then they validate in the field our results and they give us information. So the base map is transformed to forest map, taking into account all the observations that are taken to the field by experts. That's the idea. So phase one, you have the base map. Phase two, you have the forest map. Another example of the other observatory we have with the Field Forest Service, the National Observatory of Forests, in which, as I said before, we try to homogenize all the forest maps and all the forest. Each of them has got about 20 parameters. So for every polygon, whatever, we have different parameters. The idea, the problem in the country was that for every sector, for every region, there were different specifications. So it was impossible to have one complete forest map covering forest map, yes, covering the whole country. So it was easy to make decisions at local level, but very difficult to make decisions at national level. We don't care about the local forest services. We're here for the ministry. The ministry has to know where the good forests are, where the bad forest is, where it can produce wood, where it cannot produce wood. So that's the main idea. So that's why we had the idea was supported heavily by the Ministry of Environment. They want to have an overview of what the situation of the forests in the country. And this actually, there was a question before about what GS is. This is based mostly on existing data, no image analysis, mostly databases, mostly analysis what was already collected in the field by different departments, forest departments in the country. And this is more or less what you have. For every polygon, you have different information. This is how we cover the most of the country. Since the country, maybe you know the history of the country was liberated not in one go. Started from southern Greece, and then we had different times, every 50 years, we have a new part of the country joining the country. So there are different laws applied to all these areas. That's a main difficulty. And also in Greece, we have the phenomenon that some parts of the country are not managed at all. For example, the island of Crete, there is no forest management. Does not mean there is no forest in the country. In Crete, there is forest in Crete, but it's not managed. So based on this basic information, this database we have been creating, it's easy to know more or less where do you need to apply forest management. And more or less some products we produce operationally. Actually, today, the group is working on the new fires happening in the country. One is Rapitra Crete and one is Pieria Mountains in Central Macedonia. And we're working for the ministry today. There's a group of 2 people, at least, working on mapping, so they send the reports to the government. We have an online mapping service, which has been updated. This year we contract the company, and we're also talking with Planet in order to have a permanent contract with them in producing near real-time, high accurate planetary maps, etc. And this, the idea is by next year to be not in the university webpage, but to be the Ministry of Environment webpage. as a service produced by the University of Thessaloniki to the Ministry of Environment of the Greek government. I will not take long, okay? As we said before, one of you mentioned Google Earth Engine, okay? Google Earth Engine came to our life as well. We've been using that as well as a tool. Also, as you know, probably Copernicus, we have been listening, hearing about Copernicus. There is a strong component services related to land, lots of free data coming from them. Also, in situ data, maybe you know LPAS, you know different data sets that may be coming from Copernicus and can be used in any field survey or maybe verification process. Talking about some other related, maybe you know that land cover mapping is one basic information that somehow maybe is very useful for us because we know where the forest is and where the other classes are. Okay, it's not forestry per se, but it's related to all sciences, including forestry, because it separates the land to different categories. Another thing we've been doing is vegetation change detection. And it's very important now because we talk about biodiversity, we talk about climate change, and you want to know how in 20 years' time, in this case, between 1987 and 2007, how the different classes of vegetation have been changing. And that somehow we can relate to probably changes in the climate. And that's all I had to say for today. Thank you very much.